So could you talk about the free energy principle at a very high level? So introducing it again to a lay audience. So just like a repeat from last week, just to get warmed up.
Right, okay. Yes, of course. So the free energy principle is a method. So principles in physics are methods, so one applies it. What would one want to apply it to? Well, to simulate, reproduce, realize, or model a particular kind of self-information, self-organization, my apologies. And this kind of self-organization inherits from the physics of something that is individuated from something else, in virtue of possessing a boundary or a Markov blanket. And the particular mechanics that ensue from that separation of something, a particle or a person or a population, from the environment or the external states in which it is embedded, can be read as a Bayesian mechanics. So what does that mean? Well, it means you can describe the internal dynamics of something and its action upon the external states or the world, namely its behavior. We could argue sentient behavior in a very simple sense, in terms of Bayesian belief updating. So there is always at hand a description of any particle, person, or population that can be individuated from the environment in which it is embedded, in terms of Bayesian belief updating under a generative model. And that generative model effectively prescribes or defines the kind of thing you are simulating, emulating, or trying to describe. The generative model itself basically just describes the states that are characteristic of the thing in question. And the advantage of having this formalism or Bayesian mechanics as a description of self-organization is that one can write down a generative model and then just take off the shelf Bayesian update rules, sometimes described in terms of belief propagation, sometimes articulated in terms of variational message passing. Particular variants under certain kinds of generative models will be known as Bayesian filtering, or predictive coding in the neurosciences. All these are descriptions of effectively the same kind of message passing that describes the dynamics of your thing, in terms of inference. That inference formally is a tendency to maximize something in Bayesian statistics called model evidence, and this leads to a sort of poetic and neat summary of things that comply with the free energy principle in terms of self-evidencing, namely acting in a way to gather information that has the greatest evidence, or for your generative model. In other words, acting in a way to gather evidence for your world model or model of the world. The nice thing about that formulation is that it provides a complement in the sense that the log of the model evidence is also known as self-information or surprisal in information theory. So you could describe self-evidencing as exactly the same or equivalent to a tendency or an imperative to minimize surprisal self-information, or more simply prediction error, again linking to things like predictive coding. Was that okay?
That was great. And in fact, I'd like to pick up on something specific that you mentioned, which is the as-if nature of free energy principle theoretic modeling. So I think this has, come to the fore in the literature over the last bit. But and you mentioned it at the outset. A principle leads to a method. So this is at its core. This is about a way of using mathematical techniques to model physical systems. It's not really a metaphysical statement. Well, actually, maybe this is better posed as a question. Do you see this technology more as a way to describe, as it were, the fundamental nature of, say, cognition or mind or life or something like that? Or do you think this is more, a modeling methodology that, doesn't speak to say, fundamental features of mind and cognition, but is a useful way of talking about the world? Or is that maybe a false alternative?
Yeah, I mean, it's a great question. You know, the way that I look at it is that it affords a description. So it gives you a license to put a teleology on top of the underlying dynamics. So the underlying dynamics don't have a teleology. They don't have an interpretation in terms of belief updating. It is you that puts that on top. So in that sense, it is just a description. And as you point out, it only becomes a useful description when you start to use your teleology and your ontology. Say, for example, when you think you have a particular generative model that best explains the behavior of a subject of inquiry. That could be a psychiatric patient, or it could be a large language model. You've got some system that you now want to study or possibly emulate or model. And the free energy principle just gives you a procedure, a set of methods or tools that allow you to test hypotheses by putting forward a generative model that best explains the behavior of this thing. So I think that would lean towards the free energy principle as supplying a methodology, very much in the spirit of things like Hamilton's principle of least action. So Hamilton's principle of least action will not tell you how to throw a ball, but it will certainly enable you to simulate and predict and to, if to use your term, to model the trajectory of a particular instance of ball throwing. So in that sense, it is not describing any metaphysical reality. The only thing the free energy principle assumes is that this universe can be described in terms of a random dynamical system that possesses within it sufficiently sparse coupling for the emergence of Markov blankets or conditional independences, which in turn leads to something technically called weak mixing. That's the only metaphysical assumption. Everything else inherits from that, and only inherits usefully in the sense that, I repeat, you can, if you like, turn things on their head. So if you start off with asking the question, what characteristics, what kind of mechanics or dynamics must something that is sustainable and self-organizing possess? And you can articulate it in terms of belief updating or the Bayesian mechanics that rests upon a generative model. You can sort of swap that around. You can invert that and start with the generative model and then apply the dynamics, which is effectively just a gradient flow on a variational bound on the log evidence for this thing that is a generative model of its world in which it is embedded. Or you can read that, I repeat, in terms of information theory and minimize the negative of that, which would be minimizing surprise. I should qualify that because there are some interesting well, I'll qualify it in two ways. One, which I think is probably pertinent to your work and the debates that I've heard you engage in. This is not to say that the teleological application of the free energy principle and just dropping the as-ifness and saying this is a description, this is a way of articulating what things do. I do not mean to imply that it is a modeling tool that a scientist would apply to something that is observed. This is very much a teleological first-person account. It's from the inside. It's how something makes sense of its world from where it hasn't got direct access to its world. So it's not about observational science. It is about the act, or one way of describing observation in and of itself, measurement in and of itself. That can be described as an inference process. So this is if you like, a teleological description from the inside. It's not a description of how me as a scientist makes sense of you as an experimental subject. The second qualification starts to get a little bit interesting, and I'm not sure I have a clear answer from the point of view of the physics, but there are certain kinds of systems that start to that are not in a position to access directly their own actions. And that creates an interesting situation. And these are probably very rare systems, things like you and me. And what happens when you can no longer access your own actions is that your own actions now become an equivalent to an external cause of your sensations. So your outputs, vicariously through the system in which you're embedded, now constitute a latent cause of your inputs.
You call these things strange particles, right?
Absolutely, yeah. Absolutely, yeah. I'm not sure whether that will stick or hold, but yes, there are a number of reasons why I quite like the notion of strange particles. But in this instance, then, we have this sort of curious, sort of strange loopiness, in the sense that my actions, which are not random variables, they are real variables in this metaphysic random dynamical system, suddenly now, from my point of view, from the inside, become random variables, which I have to infer, or I can always be described as inferring. And if I'm now inferring my own action, I now have to have prior beliefs about my own action. Now, if that's the case, you've now got a description of a thing that's describing itself inferentially in terms of existence. So at that point, I start to wonder, is it useful to think about this just in terms of descriptions of, or as if you get these strange kind of particles that themselves are describing themselves teleologically in terms of active inference, for example, or I am a particle, I am a thing, and I have to infer what I am doing because that is a cause of my inputs, I think things become less clear. But I'll leave that open as an open question for the philosophers.
Well, one interesting thing to note in this context might be the duality of maximum caliber type modeling and free energy principle theoretic type modeling. And by the duality, I mean it's almost as if, the outside perspective that you were describing is the perspective of a scientist using, inference techniques like maximum caliber to arrive at a model of the system. And then the extra twist is, the free energy principle is it's all the same machinery under the hood, but then the question is not the model that I am forming of the system. The question then becomes, what model am I forming of the model that the other system entails? So maybe that's a way to resolve this duality.
Yeah, and practically, I think very relevant. I mean, that reminds me of this notion of observing the observer, or meta-Bayesian inference, in this special instance that you, as an observer, a measurer of your world, are now observing something that is in and of itself an observer, an inference machine. So now you've got this rather curious problem of making inferences about something that's making inferences.
That's right.
And I think that puts you in a sort of special and rather delicate position when you're arguing, should you apply the free energy principle just as a tool, a statistical tool, for example, or does it go a bit beyond that? Does it actually, describe the things that you are observing as themselves being an observer?
Well, I guess this kind of turns on the question of what the inferential aspect adds over and above the dynamics. Because, I mean, and, correct me if I'm misrepresenting the state of affairs here, but what the free energy principle ultimately tells you is if I have a description of a system in terms of, its dynamics, if I have a dynamic systems theoretic type explanatory model of a system that has a boundary, then I can always convert that description into an equivalent description in terms of inference. So when you tell the story from that point of view, it sounds as if, and this is where I would love to pick your brain and get your insights. It sounds as if dynamics is primary, and then inference is in some sense in the eye of the beholder. What we're talking about is equivalence in descriptions. Would that be a correct way to think about it, or are these descriptions in some sense equiprimordial? Because you could tell this story in the other direction. In principle, you could start from a purely information theoretic description in terms of inference, and then recover the dynamics. Correct? So are they kind of at the same level in some sense?
Yeah, well, I think that was a very nicely expressed. Again, duality or conjugacy. I think what you said in the past sentence was absolutely spot on. You can either start with the dynamics of the system and then reverse engineer the Bayesian mechanics via specifying the generative model that would explain these dynamics under the assumption that the dynamics have to be a gradient flow on the surprisal associated or conditioned upon that model. Or equivalently, you could get to exactly the same equations of motion or dynamics by starting with the generative model and then just solving the equations of motion that inherit from that generative model. Mathematically, they are just two roots to the same underlying dynamics. So, I mean, inference is a process. It is a process that can be written down in terms of dynamical, in terms of dynamics, in terms of differential equations or difference equations, hence belief updating. And you can either write down the underlying equations of motion, or you can express them as gradient flows on the free energy gradients, where the free energy is a functional of a generative model. They're the same thing. And that leads you to an interesting notion that you could leverage that duality. And indeed, in my limited contribution to the philosophy literature with Vanya Weiss, that was cast as a Markovian monism, in the sense that any dynamics, say, for example, the neuronal dynamics of my brain, it inherits two information geometries. One is the information geometry that would be associated with the probability distribution of all the population neuronal activity and all the metabolism and thermodynamics that would attend writing down the equations of motion for my neuronal dynamics. And
so
that
you might think of, for example, as the entropy of the states or trajectories that you're considering.
Yeah, and it's the kind of entropy that people actually measure. So much of, if I put my brain imaging hat on and speak to my friends in that community, that information geometry, and of course, as soon as you have an information geometry, you have a thermodynamics. So you go and read Gavin Crooks's very succinct and compelling treatment of thermodynamics in terms of information distance or information length. If there's an information geometry, there's a thermodynamics. If there's a thermodynamics, we have tools to measure that. And of course, these are fMRI, EEG, and all of those modalities that allow us to peer behind the Markov blanket of our experimental subjects and then gauge and literally measure the complexity. And you can get into the world of integrated information theory or Robin Carhart-Harris's entropic brain, or more simply, you could just say that when we do brain activation experiments with metabolic imaging or hemodynamic imaging, we are just effectively measuring the rate of belief updating as measured by or via the Zielinski equality or Landauer's principle, measuring belief updating. But the belief updating here is where the beliefs here are, as you say, the probability distributions of the internal states, the neuronal dynamics. But the other information geometry that is gifted by the free energy principle, which rests upon exactly the same dynamics, now associates any particular point in the state space of those neuronal dynamics with a probability or a Bayesian belief over external state. So now there's another information geometry where we're talking about beliefs about something else, not beliefs pertaining to the actual states themselves. And that information geometry is quintessentially representational because it's about something. So it endows information theory now with with a step beyond Shannon information. So the first kind of information geometry that you get, that you would use, say, in brain imaging, that can all be cast in terms of Shannon information theory and surprise and the entropy of the brain. That's completely different from, but rests upon exactly the same substrate, the representational information geometry that we talk about in terms of the Bayesian mechanics. But because they both supervene on exactly the same dynamics, they are conjugate, they are dual. And you're at liberty to talk about one versus the other. Interestingly, they can be shown to share the same free energy minima, for example, which means that you can leverage what you can measure in terms of the first kind of information geometry to make inferences about the teleological Bayesian mechanics afforded by the free energy principle. And that's what we do when we say, oh, I activated the visual cortex and therefore I must be seeing something. This is implicit in the all teleological exercises that try to identify and characterize the functional architectures of living things or self-organizing things most generally, and in particular things like the brain right through to intracellular events that can be also read, if you will, Mike Levin, in terms of a cognitive or a Bayesian or representational mechanics.
So stated simply for the purposes of just summarizing for the possibly lay audience that might be listening to this, one of the things that we get out of the free energy principle that are exciting to us as researchers is that it connects the entropy of the states of a system to the entropy of the beliefs that those same states encode at the end of the day. So it might be interesting to note in some sense that the entropy seems to be going in different directions when you consider it. So in some sense, what you're doing constantly in forming beliefs is maximizing the entropy of your beliefs. And that is in the service of minimizing or keeping the entropy of my body, the states that I'm composed, at bay in some sense. Would you say that's exact?
No, absolutely. That's a very, very good point. And you're very often a point of confusion. And it certainly confuses me. And just to take one particular example of this. Well, first of all, let's not just sort of consolidate that very important point.
To me, this was a very confusing thing when I was with you almost a decade ago now at UCL, like learning this stuff. This entropy going in different directions was probably the thing that took the most effort wrapping my mind around, frankly.
Yeah, and you keep having to revisit it just for a rewrap every few years or months, just to make sure you don't forget. But it's a really important point. So the entropy that we're talking about in terms of maximizing is, as exactly as say, the entropy of my beliefs about the causes of my sensations. So this is this information theoretic representational kind of belief structure or probability distribution that which underwrites the free energy, but the free energy itself is a bound upon the self-information or the surprise in the moment, or over extended period of time, the average surprise, which is the entropy of usually the blanket states, but also by implication, also the internal states. So by minimizing your self-information or surprise through minimizing free energy, you are resisting the second law of thermodynamics as generalized to open systems, thereby minimizing the entropy of your physical states, particularly your sensory and your active states. And that basically can be read as physiologically as a sort of kind of homeostasis. It's resisting the natural tendency for dissipation or dispersion due to random fluctuations or intrinsic fluctuations in they're inherent in this sort of dynamical formulation. So that's basically the phenomena that would emerge and is requisite of any self-organization to a set of characteristic states, an attracting set mathematically, that you are always trying to minimize the entropy, the dispersion of your physical states or metaphysical states. To minimize the free energy requires you to maximize the entropy of your beliefs about the causes of your physical states. And that's where it gets, that's where it really does start to get a bit tricky. So James's maximum entropy principle, I think, is particularly confusing because it has to be read in the spirit of measurement and observation. And it is the entropy of the measurement,
Right.
the consequences for the observer, the inferred distribution, which is the kind of which is the belief structure that is part of, or that corresponds to the free energy. So when we talk about maximizing the entropy in this sense, we're talking about basically keeping our options open.
Right.
And we're talking about things like minimizing the complexity of our inferences that now offer an explanation for our real sensory states. That,
well,
of course, is...
that feeds nicely into the as if narrative in some sense. So, I think sometimes when we present the free energy principle, the way we present it is things minimize surprise by virtue of existing. But adopting this more kind of as if framework, what you might say instead is the point of labeling something as a thing is that it minimizes the entropy of my observations in the future. Is there one preferable to the other in your view? Are they equivalent?
They're equivalent. I mean, again, applying the free energy principle renders them necessarily equivalent. So things that seem to resist, I don't like using the second law because the second law does not apply to open systems. The whole point of having a Markov blanket is that you're open to the rest of the universe. But in the vernacular, to resist the second law is to minimize your surprise. Just noting that expected surprise is uncertainty or entropy. So you're absolutely right. Anything that sort of exists over a sustainable period of time will look as if and will behave by definition as limiting the dispersion or dissipation of its states. And that's almost tautological. I know that you've described this, it's just the tautological statement that something exists in the states that are characteristic of the kind of thing that it is. And
right.
That's what it's saying. But to do that, and if you want to now understand this or describe this kind of self-organization in terms of some Bayesian mechanics or machinations under the hood, on the inside of the observer or the measurer, or the inference engine implied by the internal states, or you wanted to reproduce it by specifying a generative model that has these characteristic states baked into it, then what you would have to do is comply with Occam's principle. You'd have to comply with James's maximum caliber or entropy principles, whereby you are keeping your options open when you're now forming beliefs about the causes of these sensory states that are nicely bounded and homeostatically constrained. So that's the, if you like, the sort of key thing. You have to specify very carefully what entropy are you talking about. Right. Entropy is just an attribute of a probability distribution. It's like the average. So you're saying, oh, I've got a maximum average principle. Well, that's very nice. Average of what, please? And unless you specify that very carefully, it's meaningless. And you see this even in sort of physics. So if you read the introduction of the maximum caliber principle, also known as the principle of minimum path and maximum path entropy path entropy, you'll see that the title of the paper in which the maximum caliber principle is introduced is the minimum entropy production principle.
Right.
So even in the way that James was trying to describe these ideas, there's a deep sort of counterintuitive. What are we talking about? Are we talking about systems that have minimum entropy production, or are we talking about things that have the maximum path entropy? They're the same thing, but you have to specify very carefully what entropy you are talking about.
Absolutely.